all data breaches are an exploitation of the old broken trust model, and almost all cybersecurity incidents exploit the trust model as well. So this is what we have to understand. This is where zero trust comes from. It comes from the understanding that trust, the idea that you want to create this human emotion and inject it into a digital system, is the fundamental problem that we face in cybersecurity and in fact all IT today. So as we look at what's going on, right, you can see that there's this huge problem around data breaches, and this is the strategic goal of zero trust, is to stop data breaches. Because if we can stop data breaches, we can solve the thing that gets our organizations into its deepest hole, and that's a data breach. And you look at any of the data breach statistics, you look at the consequences of data breaches, they're just so significant to the organizations that suffer them. And these statistics about the cost of data breaches, I think, are actually underreported. There's a lot of data breaches that no one knows about because legally people haven't been forced to report them. So this is a huge underestimation of the cost of data breaches. It is far and away the largest cost we have in cybersecurity and in IT spend over the course of any given year. So this is the problem that we must solve. Now, what we're trying to do is, with zero trust, is solve a couple of significant problems. You know, we reduce the opportunities for somebody to successfully attack you, right? So when we talk about attacks, somebody coming in and trying to attack your network, a successful attack is either a disruption of a system and, more significantly, a data breach. And so there's several things that zero trust solves, right? It reduces the opportunities to attack because we're focusing on protection. It solves the problem of just allowing everybody free access to systems. As a former pen tester, and anybody who's done pen testing knows there's always a way to get into anybody's network, and you'll find when you get in there that you have access to almost everything because of this broken trust model, that once you get into the network, you are free to do whatever you want to inside that network because you're trusted. Put big air quotes around that word trusted. And then we limit access to sensitive data. That is the action that we're going to take. And data in this context is also assets, right? Digital assets. But when we solve data breaches, right, what are the things people are trying to steal? They're trying to steal data. Data has value. You can monetize data, whether it's credit card numbers or whether it's credit reports or whether it's statistics around things that you're doing for advertising revenue, or whether it's formulas for some product that you're creating, whether it's intellectual property. There's just all kinds of data out there. And then by doing this, from a security operations standpoint, there's a huge benefit because there's much less things that you have to look at, right? Right now, you have to look at everything coming into your network, and we're worried really about things exfiltrating your network. And so this is the fundamental problem, is exfiltration, much more than infiltration, and we misunderstand that. We're still so input focused that we're not output focused, and what gets us in trouble is if the data exfils from our organization. So as we think about this, right, the legacy systems that we have that go back, to last century, where we trust all internal traffic by default, gives us unrestricted access to the inside of the network. And where we need to go is eliminate this idea of trust. Trust is a four-letter word in the world of zero trust. Anybody who tells you that the goal of zero trust is to make systems trusted doesn't understand zero trust. We're trying to eliminate human emotions from digital systems. And so all data and access must be approved by a policy that controls access to the data and inspects that access, the whole traffic going to that asset, that data, all the way through layer 7. So we cannot apply this emotion to digital systems anymore. We just have to eliminate that. Now, the best example I can give you is how the U.S. Secret Service protects the President of the United States. This is an image from President Obama's inauguration parade in 2013. And you'll see that the U.S. Secret Service knows 3 things about the President that we don't know about the data and the assets that we're protecting. They know who the President is. That's the first thing. They don't wander around wondering, hey, I wonder if that person is the President. They know where the President is at all times, and they know who should have access to the President at any given time. These are the 3 fundamental questions that need to be asked about anything that we're protecting. So you can see here that while there is a perimeter set up on this inauguration parade, it was a cold day, and if you look up at the uniformed Secret Service officers up in the upper right-hand corner, you'll see they all have their hands in their pockets. Why? Because that's not really where the primary protection is going to be coming from. What the Secret Service has done is defined what I call a protect surface. This is the fundamental concept of zero trust. What do I need to protect? On this day in 2013, the only thing that mattered from a protection standpoint were the 4 people inside of that armored limousine called the Beast, the President, his wife, and his 2 children. The attack surface was reduced orders of magnitude into a protect surface. So a protect surface just is the smallest subset of the attack surface that we can possibly have, and it's always knowable. You can always find that out. And by understanding the protect surface, you can now move your controls in as close as possible to the protect surface in order to fully take advantage of the ability that you have with your controls. And by doing this, moving those controls in right up next to the protect surface instead of out the edge at the perimeter, you now define a micro perimeter around the protect surface. This is a key component here. The perimeter is not dead, as I hear people say. The perimeter is micro. And in any micro perimeter, there's very few people on this day that ever need to transit the micro perimeter, right? You going in or out. Very few people. And that's what happens in zero trust if we define a micro perimeter in policy, is there's very, very, very few times that something has to cross that perimeter, that micro perimeter, and so therefore the policy is massively reduced. Now, the Secret Service doesn't stop there. They constantly monitor and update in real time, and this is what we do in zero trust. So this is a zero trust model of executive protection, but it's also the best analogy that I can give you in terms of visually, humanly, how we're going to design zero trust networks. Now, you know, lots of people are deploying zero trust networks. One enterprise security architect for a state government here in the United States said, our network is like the Wild West because we host so many disparate systems. We need to contain everything, and that meant taking a position of zero trust. Look, this trust model that was promulgated in the 20th century, that was just a fundamental misunderstanding in an attempt to humanize concepts that people really didn't understand yet. But that's what we have to get rid of. And so as we start going down that, we're going to take a completely different approach to how we design networks in the future. Now, there are four basic concepts that we have when we're building zero trust networks. First is we define the business outcomes. We focus on what the business needs to accomplish. And this is something that IT and security has done a poor job of up until now. As I go and I meet with business leaders around the globe, they often feel like IT and security don't understand what they're trying to achieve, and therefore don't build systems that focus on the business outcomes. And so often, especially in security, we're seen as an inhibitor of business instead of the enabler that we should be. Secondly, we design the network from the inside out instead of the outside in. In the old model, the way I learned how to design networks, and you did too probably if you've ever designed a network, is from the outside, from the CPE equipment, from the router, and then you put in the core switch and all of the layers of the switching infrastructure, and then if you're forced to, you start overlaying security on there. And that builds networks that have really no security because you don't understand what you're trying to protect. So in Zero Trust, we start at the protect surface when we design outward from there. So we understand what we need to protect first, the data, the applications, the assets, and the services that typically go into a Zero Trust network. Then we determine who or what needs to have access to that system, and we define this in policy. And we limit it based upon someone's need to know on least privileged ideas so that people don't have the opportunity to steal data that they don't need for their business. So when we look at big data breaches like the Snowden or Manning breaches, you'll see that those people had access to data that they didn't need to have access to in order to get their job done. So the breaches would have never happened if we would have controlled access based upon their need to know. And then we inspect and log all traffic. It's not enough to control access, which is one of the myths and misunderstandings of Zero Trust. You have to inspect that access and log it all the way up through layer 7 so that we can apply layer 7 policies. Every hacker knows how to get through basic security controls that only go up to layer 3. So we need to inspect and log all the traffic while we're controlling the access. Those two things should be done together. Now, the foundation of Zero Trust, like I said, is the protect surface. And the protect surface is the thing that we're protecting. So it could be data. So we've got source code or customer data that we put a microperimeter around. And we're using a segmentation gateway, which I'll talk about in just a moment, as the way to enforce the security policy around that. It could be other things like applications, like a human resource application that we want to have a microperimeter around. It could be a certain asset like a PLC in a manufacturing plant. And so we need to think about all the kinds of things, including services, Active Directory, DNS, DHCP. Those are services that I often put in a Zero Trust network so that I can have much more granular control over the policy around how those things work because they're critical to the business and they can't just sit out there with everybody having access to them. And so once we understand the protect surface, we can then segment the network properly. So segmentation, a lot of people are, I need to segment their network, and then they fail on it. And the reason is segmentation is a technique, not a strategy. And so the strategy you're going to use is Zero Trust. If you are saying, well, we need to do network segmentation, what you're really saying is we need to do Zero Trust as a strategy. And then Zero Trust defines how we're going to do segmentation. It tells us why we're segmenting. We're segmenting because we're defining the protect surface. If you segment in just an ad hoc way and think if you break up the network into really small pieces, somehow that's going to provide you some protection, that's not going to happen. You're actually going to probably make the network less usable, less powerful, increase latency, do a lot of bad things to the network because you haven't thought about why you're segmenting. And then the other thing we have to do is we have to enforce segmentation all the way up to layer 7 with a segmentation gateway. This is a next generation firewall when used in a zero trust environment. I call that a segmentation gateway because it's a gateway designed to segment networks in policy layers 2 through 7 based upon data, applications, or users. And so once we understand that, then we can use the segmentation gateway to provide a segment that is defined by the microperimeter. And so we can do that in policy. And it's really amazing what we can do when we start abstracting off the infrastructure and start thinking of security policy as the way to do segmentation. So as we extend this out into other parts of the network, right, we can do this in branch offices, we can do it with mobile users, we can do it in data centers, we can do it in the corporate network, because we have a way of doing it, right? We've defined the critical assets and data that go into our Protect surface. We create zero trust policy based upon the data, the identity, the business need, and then we monitor and update that in real time and make adjustments based upon things that change in our environment and the information that we gather from that monitoring. You know, one of the important things about monitoring and logging is that we have to log all the good stuff and the bad stuff, right? Because if you think about it, a data breach happens in the allow rule. So we need to have all this stuff coming into our network, and then we need to do machine learning and all kinds of stuff against it so that we can gain more and more knowledge about how to protect the network better. And then we're going to add other things into it, like multi-factor authentication and all kinds of identity stuff. And there's just so much stuff that we can do if we start and get the fundamentals right. And the fundamentals are understanding what we need to protect. So here's an example of what we're doing with MFA and enforcing that, right? So if you have a legacy system, if you can enforce multi-factor via policy inside the segmentation gateway, a lot of those systems that can't support higher levels of identity, multi-factor authentication or biometrics or whatever, because you can't programmatically build them into the system, we can enforce that with the segmentation gateway at layer 7 and prevent credential theft and abuse. These are really, really important concepts as we start thinking about how these networks work, because almost all networks are going to have a combination of newer modern apps and legacy apps. You know, people think there's no more mainframes out there. Yes, there are. There's lots and lots of legacy systems. And there will probably always be those legacy systems because it's too expensive for some of these systems that work really, really well to rebuild them and recode them into a modern system that we think about. You know, it doesn't make sense from a business perspective. So again, we're looking at what the business is trying to achieve. Now, zero trust works in the physical world, but it also works in the cloud as well. It's the same exact concepts, and we need to understand that we're defining protect surfaces in clouds as well as in physical data centers that we own. And that concept of what do we need to protect works everywhere and will certainly always work everywhere. That's why zero trust is a strategy that can shift and adjust to whatever the technology is below it. When we have that correct strategic focus, we can win inside of any specific environment. So when we look at extending zero trust to public and private clouds, one of the things that you need to understand is the public cloud and the private cloud are the exact same problem from the security perspective, right? They're a problem of virtualization. I define a public cloud as someone else's virtual environment that you put your data into, right? So what you need to protect is the stuff that you put into the cloud. And you do that by inserting a virtual segmentation gateway, a virtual version of a next generation firewall as a zero trust enforcement point directly into the virtualization stack inside the public cloud as a transparent service insertion. You'll do this in public clouds, in private clouds, and you must have centralized policy that provides consistent policy and management for your public clouds, your private clouds, and even your physical environments. Everything should have the exact same policy. The policy based upon protect surfaces, upon data and applications doesn't depend upon the physical location of the enforcement point. It depends upon the traffic and the data that's accessing the traffic, or the data that's being protected through the access of the traffic. So these are things that we need to really, really understand, and by focusing again on that protect surface, we can win in cloud security as well. So now you say, oh, what about the endpoint, right? Everybody's saying we should protect the endpoint, and we should protect the endpoint. Now, the endpoints generally are the things that people use to access data, whether they're legitimate actors or malicious actors. And so we need to, again, do the same three things, but we need to define critical assets and understand where they exist and how people get access to them. And then one of the things we're going to do is extend the policy from the protect surface to the endpoint, and that's often done by a VPN type of technology. And then we need to prevent malware and exploitation on that endpoint as well. So, and then all of that data that we gather from the endpoint security has to go into our data lake where we do all of our logging and everything so that we can then continuously monitor and update that. And so these are the key concepts that we're doing from the endpoint. You can't just say, oh, I'm putting security on the endpoint and that's going to solve all my problems. It doesn't, right? It absolutely doesn't. And endpoints work different than a network, and we have to extend the network to the endpoint. And that can be a difficult thing to do. So that's why we leverage the policy of the segmentation gateway to perform that function. And you can see here, right, what we're doing, right? We have endpoint protection and VPN technology on the endpoint. That means that the policy follows the data and protects it everywhere that it exists. And that consistent policy is extended from the segmentation gateway to the endpoint. And this is really, really key. And then the endpoint protection will sit on the endpoint and stop it from being exploited and being used in an attack. And also by extending the policy to the endpoint via the segmentation gateway, one of the things that we're doing is reducing the amount of traffic that has to be looked at by the endpoint protection solution. And this is certainly critical. And we need to not look at every single. If we don't allow every single piece of traffic to come in and hit the endpoint, we can reduce the work that the endpoint protection solution does. So when I'm designing these networks, I'm leveraging what Palo Alto Networks has, what we call our security operating platform, where we take our network security technologies, our endpoint security technologies, and we deliver it into an entire platform where we can do some really amazing things by bringing all these things into a singular cloud, making them all work together, and then extending them with our application framework where we have applications that we've developed that do machine learning and analytics and various things, as well as third-party apps, and then apps that our customers build and use our APIs and our SDK to leverage that application framework. That's what I'm leveraging when I'm building zero trust networks for my clients. So we can then leverage all of these technologies, like our next generation firewall technologies, whether physical or virtual, function as segmentation gateways. We can leverage our logging service to bring all the data together. We can leverage our endpoint protection solution, traps, to protect against exploitation. We can leverage our global protect solutions to extend policy from the next generation firewall to the endpoint, and we can leverage our API-based cloud security technologies to provide security for public and private clouds. And so this is the value of a platform. Platform is really, really important, and this is why I came to Palo Alto Networks. So now's the time to do zero trust. But there's a couple things to understand. It's okay to start small, right? You're not trying to flip a switch and turn your entire network into a zero trust network. It is designed to augment what you're doing and to grow with you. So you start very small. But if you have new initiatives, refreshes, or especially cloud deployments, if you can start fresh, that's awesome. That will make your life easier. And then you must go with a platform, right? You must have things that work together. Having disparate technologies that don't interact is setting yourself up for failure. That will be your destiny. So you must have a strategy, zero trust, to prevent successful enterprises across your entire environment: cloud, mobile, endpoint, on-site data centers, your private cloud, everything. You have to think of it as a single system. Now, we're seeing tremendous amount of momentum in zero trust. I started it over 10 years ago in a series of speeches, and then spent 2 years doing the research and validating it before writing the first white paper in 2010. And then we started seeing, lots of movement. So in 2012, I started helping people deploy and design these networks, and just started to see a ton of adoption. And then you started to see big companies come out and publicly endorse and saying they're doing it. So Google in 2014, Netflix in 2014, Coca-Cola came out in a series of speeches and started talking about it. And then the big shift was in 2016 when the U.S. House of Representatives came out and asked all government agencies to start deploying zero trust in their agencies in the wake of the OPM data breach. And if you're not familiar with the OPM data breach, you should. It's a fascinating study, and the U.S. House of Representatives, one of their committees, wrote an entire report on it where they came out and said that all agencies should move towards a zero trust model. And so it was that led me to join Palo Alto Networks in order to scale the strategy and take it to critical mass. And what we've seen is a validation of that, where last year, 2018, we achieved the highest score in the strategy category, and were a leader in the Forrester ZTX, or Zero Trust Extended Ecosystem Wave. And so what we've seen is just this huge validation, to the point where a